Okay, Math 111 Web Exam 1 Review, Video 3, starting with number 8 here. So number 8, we're finally getting past that middle part of the Chapter 4, where we're using those rational root theorems and finding complex zeros and doing that big factoring tool. So we're finally moving on from that and getting to rational functions and rational expressions. You know from your reading that rational expressions, rational equations, are anytime you have a fraction of polynomials. In your division section, we know we can perform this division. If it comes out clean, we can get good results. But if it's not a clean division, we want to still be able to handle how that behaves. And again, from your section, you know that there are a couple things that we often look for in these. We are going to be looking for x-intercepts. We're going to be looking for y-intercepts. We'll be looking for horizontal asymptotes or slant asymptotes, depending. And we'll be looking for vertical asymptotes. I think this question, instead of asking for x-intercepts, says find the zeros. It's the same thing. You want to be comfortable with the fact that x-intercepts, zeros, and roots are all exactly the same thing. Not exactly, but they're essentially the same thing in terms of the mechanics that we have to perform. So in general, anytime you want to find x-intercepts, you set something equal to 0. So if you want to find x-intercepts, we're going to take the thing and the function set equal to 0. The nice part is, because this is a fraction, fractions are equal to 0 when their numerators are equal to 0. As long as the denominator isn't also 0, which would make us undefined, as long as the top is 0, the whole thing's going to be 0. As long as that bottom isn't also 0. So to find our x-intercepts, we're just going to, or our zeros, we're just going to take the top set equal to 0, factor if possible. These are usually nicely factorable, by the way. So we get x equals 4 and x equals negative 2. So those are our zeros of the numerator. So these are our possible x-intercepts. The only way they're not an x-intercept is if they also make the denominator 0. The nice thing about denominator is when we go down here to vertical asymptotes happen where the function is undefined. Well, the function is undefined when the denominator is 0, so we already have a purpose down here for vertical asymptotes of figuring out when the denominator is 0. So we might as well do that to find our vertical asymptotes. Divide both sides by 3. Divide both sides by 3. Factor x minus 2, x plus 2 equals 0. So the denominator is equal to 0 at x equals 2 and x equals negative 2. That means these are our possible vertical asymptotes. The only time one of these x-intercepts isn't really an x-intercept, and one of these vertical asymptotes is not actually a vertical asymptote, is when it occurs on both lists. X-intercepts happen when the top is 0, but the bottom is not. Vertical asymptotes happen when the bottom is 0, but the top is not. If it's on both lists, it is neither. It is not an x-intercept, and it is not a vertical asymptote. So that has to be removed from both lists. Be careful about that. So we have our only x-intercept at x equals 4. We have our only vertical asymptote at the line x equals 2. We still have to find horizontal asymptotes, if any, and y-intercepts, if any. Let's go with y-intercepts. Y-intercepts are generally nice. Every y-intercept has an x value of 0 and then some y value. That's how you end up on the y-axis. So if you ever want a y-intercept, just let all your x's be 0. You're finding f of 0. So 0 squared minus 2 times 0 minus 8 over 3 times 0 squared minus 12 is negative 8 over negative 12, which is what? Divide by 4, so you get 2/3. So the line y equals the point 2/3 in the y. So 0 2/3 is the y-intercept. Generally very nice to find. Let me make that 2 a little clearer, sorry. So again, anytime you want to find a y-intercept, set the x's to 0. Anytime you want to find an x-intercept in anything, set the whole thing equal to 0. We're only setting the top equal to 0 because we know how fractions behave. Now, horizontal asymptotes is a slightly different argument. Horizontal asymptotes are about end behavior, so it really depends on the degree of your polynomials. And your book does a fairly good job of going through the possible cases. It really depends on which one of these is more powerful than the other. And by powerful, we're really speaking about the degree. If the top is more powerful, it's eventually going to become so large that dividing it by something really isn't going to keep it smaller. So if the top is more powerful, you don't have any horizontal asymptotes. It never levels off. If the bottom is more powerful, has a higher degree, then eventually this numerator is going to be, big numbers. It might be 10,000, 100,000, but this denominator is going to be millions and billions. So you're going to have very large numbers on the bottom with not nearly as large numbers on top. Value is going to become smaller and smaller and smaller. If the bottom is more powerful, you have a horizontal asymptote at y equals 0. Again, your book goes through these arguments. On this particular one, they are the same. They're both degree 2. So if you imagine putting in a large number for x, like even 100, 100 squared is 10,000. 10,000 minus 200 minus 8 is somewhere around 10,000. So that top is going to be 10,000-ish. 10,000-ish at x equals 100. The denominator is going to be, again, 100 squared is 10,000 times 3 is 30,000 minus 12 is still 30,000-ish. So 10,000-ish over 30,000-ish is about 1/3. If you let x equal 1,000, this will be 1,000,000 minus 2,000 minus 8. This will be about 1,000,000, and this will be about 3,000,000 minus 12. So 1,000,000-ish over 3,000,000-ish, still about 1/3. Whenever the degrees match, the horizontal asymptote, where it's leveling off at, is the ratio of those lead coefficients. That denominator is always 3 times the size of the numerator. So these will always essentially cancel out to about 1/3 for large x's. So a horizontal asymptote is at y equals 1/3. You want to get those 3 cases down. If the top is more powerful, no horizontal asymptote. If the bottom is more powerful, horizontal asymptote at y equals 0. If the degrees match, then it's the ratio of the lead coefficients. Read through that section. So, what do we know? Let me give myself a clean piece of paper here. We have determined, change to white. We have determined that we have an x-intercept at x equals 4, or I should more formally say the point 4, 0. X-intercepts are points, so we should call them that. We have a y-intercept at 0 2/3, so a y-intercept at 0 2/3. We have a vertical asymptote our vertical asymptote was happening at x equals 2, and that is the line x equals 2. So we want to make sure we express it as a line. And a horizontal asymptote at y equals 1/3. So a horizontal asymptote at y equals 1/3. We also have this weird point at x equals -2. That didn't make a x-intercept, and it didn't make a vertical asymptote, but it does do something to our graph. So I just want to note that we are undefined for x equals -2. And I'll show you what that does in a second. So if we're going to look at all these things to try to graph this, I need some axes. We have an x-intercept at 4, 0. 1, 2, 3, 4, 0. And no others. We have a y-intercept at 2/3, so that's barely at once right there. When that 1/3, I should change the scale. Let's make that 1. So that's 2/3, so that's going to be our y-intercept. And down here at 1/3, we're going to have our horizontal asymptote. And a vertical asymptote, that is y equals 1/3. And a vertical asymptote here at x equals 2. Now, in this, those classic rational function sweeps have to live. So if we want to figure out where those have to be, that's this in this region. That sweep either lives down here between the horizontal asymptote and the vertical asymptote, or it's up here. Now, if you're unsure where it is, you can just plot some points, pick some x values, like x equals 3, see if it's above or below that line. But because there's not an x-intercept here, we really can't have it come from down here up to that y equals 1/3, because it would have to cross the axis, and that would be an x-intercept. And we don't have an x-intercept. So it has to be up here. Down here, we can either come down from there and level off, or come up from here. But we know because of this x-intercept, we have to pass through. So we're got to come down or up from down here. Then we know we have to pass through our y-intercept. So we're going to have to keep coming up past that intercept. A lot of people get nervous when you cross horizontal asymptotes. You can cross horizontal asymptotes all you want, as long as you level off in your end behavior. Vertical asymptotes are more dangerous. You can't pass through vertical asymptotes. But horizontal asymptotes, you can pass through a couple times if you have to. Now, it's not going to come all the way back down because it doesn't have another x-intercept. So it's just going to kind of come down and be asymptotic, that is a word, to that y equals 1/3. Now lastly, I told you that this x equals -2 would do something. I do want to show you what that does. All it does is at -2, 1, 2, this function can't actually exist, because at -2 it's undefined. But because that -2 was a 0 in both of them, it's kind of like the 0 compensates for itself. So it doesn't cause this kind of panicky asymptote. It just makes a little hole in the graph. So this little tiny, infinitely small little hole, little spot where the graph doesn't exist. And that's going to happen whenever you have one of these zeros that are in, both lists that kind of cross each other out. Instead of making an x-intercept or a vertical asymptote, all it makes is a little hole. Not an x-intercept, not a vertical asymptote, just a little hole. Graphing these takes lots of practice, particularly the horizontal asymptote, logic, and just keeping your ducks in a row, keeping yourself organized. Do handfuls of these. Your chapter has a fair amount of them. Your homework has some of them. Spend some time with these. They take quite a while if you're going through them, talking through them and being kind of laborious about it. But if you get good at these, you can go through these very quickly if you're practiced with them. Or if you're not practiced with them, you can lose a lot of time fighting with them. So be careful. So that was number 8. Let's see. Oh, that was our chapter 4 stuff. Good. Then we get to move on to chapter 1, 2, and 3, the more review-oriented material. Again, I'm going to want to go through this a little faster. Number 1 on the 1, 2, 3 review says build the equation of a line in slope-intercept form passing through -5, 7, and 2, -1. This is your classic line skill. You have to know how to make a line passing through 2 points. It's not going to go away. It's going to be an important part of everything else we do. So in one way or another, we have to determine our slope. Our slope is the change in the y values over the change in the x values. You have to know that relationship. It will not be given to you. One of the things I recommend is labeling. Call that x1, y1. Call that x2, y2. Really quickly labeling those will help you stay organized. I think I said that in one of your other videos. So -1 minus 7 over 2 minus -5 gives us a -8 over, what is that, just 7? So that's our slope, -8/7. To build the actual line, we know it has to be of the form y equals mx plus b. That -8/7 is our m. We have to find that b. We can do it in a couple different ways. I think I illustrated them in your quiz thing. Any of the methods are fine. I'm going to use the modified point slope method. So y will equal our m x minus one of our x values, doesn't matter which. I'm going to use this x1, so plus 5, and then plus the y value, plus 7. Some people like to have the y minus y1 on this side. That's perfectly fine. I like it the plus y1 over here. It's up to you. It's your problem. As long as you have a method that is consistent and works, I'm more than happy with that. So distribute the -8/7. We get what? -47 plus 7 is 49/7 when you get common denominators. 7. So y equals -8/7 x plus 9/7. You've got to be able to take 2 points and make a line like this. It's going to come up over and over again. It's going to come up in your economics classes, your sociology classes, your chemistry, your biology, certainly calculus. We do a lot of lines in calculus. So this is a skill that is so important. Anytime I get a chance to evaluate you on it, I'm going to take it because I need to make sure you guys can do this before you head out. And if you do know how to do this, great. I'm going to give you free points all the time because I'm going to keep having you do this. Number 2, build equation of the line in slope-intercept form perpendicular to your other answer. Okay, well, this line here was y equals -8/7 x plus 9/7. So if our original slope there is -8/7, in number 2, we're trying to find something that's perpendicular to it. So if a slope is -8/7, the slope of a perpendicular will be, change the sign, flip it upside down. People often say the negative reciprocal. That's great. The slope of our perpendicular is going to be 7/8. That is the only piece of information we want to take from question 1. The only thing we're told about question 1 is we have to be perpendicular to our line in question 1. Our line in question 1 had the slope -8/7, so that means in question 2, our perpendicular slope will be 7/8. The y-intercept, the 2 points in question 1, none of those matter. We have this slope. The question 2 also says we have to pass through the origin. Origin is the point 0, 0. So we have to make sure we have this point and this slope and pass through that point. So y has to equal 7/8 x minus 0 plus 0 if you want to get that formal about it. So y will equal 7/8 x. If this was a more complicated point, that complicated point goes and builds your line. But be careful about trying to use the 2 and the 1 or the 5 and the 7 or the other information from question 1. The only thing relevant from question 1 is the slope that it gives us. So that's the answer to question 2. And it does tell you to graph them. You should be able to graph all of these. Any line you should be able to graph. Again, you'll periodically get free points for knowing how to graph stuff or lose points for not knowing how to graph stuff. But, real quick, we got a y-intercept at 9/7, so graph 9/7. The slope of -8/7, so drop down 8, go over 7, make your new point. I'm hoping you know how to graph lines. If not, look it up. Come see me. I'll help you learn how to graph lines. That's kind of why we're here. Identify some of those things. If those are struggles for you, let me know, and we will clean those up. But at that point, you're going to be wanting to come see me, come see the other tutors, get that extra help. Let's see, it's been about 20 minutes again. So number 3 on the 1, 2, 3 review, I think I'll come back and make another one for.